Just like we learned in the heat transfer unit, some things act as conductors, some materials act as insulators. So materials can conduct and insulate heat, like we've talked about. Now we're going to talk about materials conducting or insulating electricity. So an electrical conductor is one that electricity can easily flow through. For example, metal, specifically copper, that's the best one, that's why it's used in all electric wiring. So metal, water, plastic, these are all good conductors of electricity. An electrical insulator is something that electricity cannot easily flow through. So for example, rubber, styrofoam, or your skin. These things block the flow of electricity, so they're called insulators. That's why electrical power lines are wrapped in rubber, so that they don't conduct electricity all over the place. That's why when I touched the Van de Graaff generator, my skin was an insulator. It stopped it, so it didn't transfer the electricity all around the room. My skin absorbed it. It was an insulator for electricity. Insulators are also resistors. So resistors are the technical name for an electrical insulator. A resistor is something that slows the flow of electricity. It's measured in ohms. This is the symbol right here for ohms. And this is an electrical circuit schematic showing the proper universal symbol for resistors, this little zigzag teeth kind of thing. So the zigzags are how you draw resistors. Again, the battery, these series of 4 lines like we've already learned about. So a resistor is something that slows the flow of electricity. So if there are 3 resistors on the circuit, you can bet that light bulb will be pretty dim, or that doorbell will be very faint. You could barely hear it. So the more resistance, the less electricity can flow. Which brings us to our next point. So the greater the resistance, the less the current can get through. So in the Snap Circuit Lab, you tried different level resistors. The 1000 resistance was not that bad. The doorbell was still pretty loud. But as you got to 100,000 resistance, things started to get really faint. You could barely even hear the doorbell. And like you saw in the simulation, good resistors are bad conductors. Resistors and conductors are opposites. So an eraser is an example of a bad conductor, but a good resistor. The rubber duck, it was a bad conductor, but it was a good resistor. So there are a few things that influence resistance, such as the material of the wire, the thickness, the length, and the temperature. So go ahead and press pause, get all these notes, and then resume the video when you're ready to move on. The last part for today is going over the objective that we set out the day with. So we started the day with trying to answer this question. Students would be able to explain the relationship among voltage, current, and resistance in a circuit. Here's a summary of what all of this means. So the voltage is what causes the current. My battery caused the electrical current, which traveled through the wires to light the Christmas bulb. The size of the voltage source determines the amount of current. So if I use a AA battery, it has a lower voltage, it would have a lower current. If I used a huge car battery, that would be a huge current that was created because the voltage of the car battery is so much greater than something like a AA battery. And lastly, resistors decrease current and thus voltage. So I'll have a certain amount of voltage always coming off of my battery. But once that voltage as well as the current hits a resistor, both would decrease.